Alrighty, so I have 10 o'clock. So we are going to get the show started this morning. So thank you for everyone attending virtually for our next Eastern Region Science Sharing webinar this morning. We have a really great topic on hand this morning, and that is talking about NBM specifically and having a discussion about what's coming with NBM 4.2, what's on the horizon, and then, let's chat, like the title says. Have a discussion between the field and the developers this morning about all that's coming in 4.2 and beyond, and bigger picture questions you have from the field about NBM details, components, and everything in between. We'll get into those conversational points later. First off, just a couple of housekeeping items. Per NBM, not NBM, per NOAA OCIO policy, please keep your mics muted and cameras off unless you're speaking or presenting this morning, just to eliminate recording any unnecessary content that could prevent the recording from going forward. So appreciate that in advance. And if you have any questions, please feel free to throw them in chat. We'll answer them in kind following presentation or by raising your hand. So first, going to start off with the introductions of our speakers this morning. First, we have Jeff Manikin. He is the chief of the Statistical Modeling Division at NOAA's Meteorological Development Laboratory, MDL. Prior to that, Jeff worked at the EMC for over 25 years, first working in the mesoscale modeling branch on development and implementations of the RUC, RAP, HER, NAM, SHREF, and high-split models. Long list. And then in the verification, post-processing, and product generation branch, focusing on verification and validation. He served as the EMC verification project lead and was a co-chair of the Unified Forecast System Verification and Validation cross-cutting team. He also led EMC's model evaluation group, coordinating formal evaluations of proposed model implementations and working with the field to identify and document model biases and issues with forecast and forecaster needs. Second, we have with us this morning Dave Rudak. Good morning, Dave. Began his career at MDL, or TDL back then, in May of 1999, and has worked in various divisions throughout his career. He first worked directly with Dr. Bob Galan in programming the post-processing portion of the MOS 2000 system, which generated MOS forecasts. He then moved into the LAMP group, where his focus was on the development of aviation products such as visibility and obstruction to vision. In 2013, he moved into the MOS group, where he developed ECMWF MOS and other MOS guidance. His most recent work focuses on the NBM, where he is currently the team lead. Jeff and Dave, thank you so much for being with us this morning. Welcome to the Eastern Science Sharing webinar series. You have the floor.
All right. Good morning. Thank you to Jordan and to Paul for the invitation to join you today. Dave and I are thrilled to be here and talk a little bit about NBM version 4.2. And then there was a special request to talk a little bit about documentation of the NBM, how people can learn more about how it works and such. So we'll spend a little bit of time at the end focusing on that. So I'm assuming my screen is visible here. I won't go through the whole list of developers, but again, right at the top, Dave Rudak, who's here this morning, is our NBM project lead and has coordinated all the work that's been done here to generate this upgrade. And I'll note our NBM Science Advisory Group. Justin Arnott is your Eastern Region representative. So I want to give a shout out to Justin. And as always, thanks to all of the SUs and field forecasters for the valuable feedback that we get on the NBM, which continually helps us to improve the products. All right, a very quick overview here of changes in 4.2, and then we'll go through them individually. So there's new quantile mapping based 10-meter instantaneous wind speed and wind gust, elimination of lattice-like features in our snow amount guidance, some pretty significant modifications to the snow liquid ratio calculation, removal of blocky winter features, improvement in precip type probability fields, and some changes to the mixing height calculation. So spend quite a bit of time here talking about winds because this is the real heart of the upgrade. And this set of changes was largely into response to a lot of concerns we heard after 4.1 went live a little about a year and almost a year and a half ago. It's been a real challenge in the NBM for wind speed and gust. It's a really hard thing to do. Version 4.0 had a notable low bias. 4.1 then had a pretty notable high bias for especially in the intermediate range, the kind of the day-to-day winds. You'll see that in 4.2, we're going to have a little bit of a low bias at the higher thresholds, but I think in the day-to-day winds, you're going to see some pretty significant improvement. So we've added these what we call quantile mapped wind and gust to the 0, 6, 12, and 18 Z NBM cycles. That's in response to that high speed bias in 4.1. And also the new products that come out of this support fire, weather, and IDSS needs. Now, the implementation wasn't straightforward, didn't quite go according to plan, but we made a really important pivot that's worked out well. We originally got a scientific approval to proceed with the next step in the implementation. That's handing off code to NCEP Central Operations. We got that approval in early September. The full 4.2 wind and gust stats looked pretty great. But after the briefing, we found that there was a pretty significant low speed bias for higher thresholds. So we had a long discussion with our science advisory group, that's the SAG, and our SMD, that's our statistical modeling division. We decided to try to address the low wind speed gust bias before handing off code to NCO. So we made some changes, which we'll talk about. And we had a secondary evaluation period conducted in the fall and early winter. That period was successful. We got scientific approval for the updated package in late January. And right now we are on track to implement on Wednesday. So again, we've introduced quantile mapping of instantaneous wind speed and gust. But as I said, we found a significant low speed bias for higher wind speeds. If you look at the overall stats, they look amazing. If you start parsing it down by thresholds, you'll see significant speed bias for higher winds. So the quantile mapping approach, it creates what we call cumulative distribution functions, CDFs, for analysis and forecasts. And we had been using a single analysis CDF for each hour of the day. But that means, again, if you break it down, you have a separate CDF for each hour of the day. You get small sample sizes, especially for the stronger wind speeds during the late night and early morning, which are fairly rare events. So we did some testing with just using a single analysis CDF that covers the entire day. But that had the undesirable effect of reducing the wind speeds during the peak wind hours of the afternoon, because if you loop in all of the weaker wind times of day with the stronger ones, you're going to potentially cause some harm to the strong winds, strong wind time of day. That's exactly what happened. So we went back to the SAG, and we went back to our idea of creating an analysis CDF for each hour. But this time we had flexible time windows. In other words, using OBS from multiple hours to increase the sample size. And what that looked like is shorter time windows in the afternoon hours when the peak winds are. So you don't sample the winds in the middle of the night, but longer time windows during the night when maybe you want to sample a little bit of the daylight hours and those stronger speeds. Just to explain what like a 13-hour window means is that at 9Z, you would use the analysis data from 9Z and 6 hours on either side, so 13 total hours. So we did that. We found that the wind speeds for the peak hours were still too weak due to sampling too much into the morning and evening hours. So we actually chopped down the time windows for the afternoon hours down to a 3-hour window. But we still had some problems in the early morning hours, and we decided that we wanted to retain the longer window at night and shorter window during the day, but we wanted a more gradual transition in between. In this bottom row here, this is the final configuration in 4.2. Again, short time windows during the afternoon hours, longer time windows at night, and a more gradual transition in the middle. So this is what the stats look like. These are all computed against IRMA verification. We have mean absolute error, MAE, and bias. And the green is going to be the ops 4.1. The blue is the what's coming version 4.2. If you look at the stats, again, they look phenomenal. The 4.2 has a lower MAE, which you want. And for bias, you want a bias close to 0. Notable high bias in 4.1. Really nice looking bias here in 4.2. But again, that's with all wind speeds grouped in together. If we start breaking it down now, all speeds upper left, greater than 14 knots upper right, greater than 23 knots lower left, greater than 32 knots lower right. Now what you see is the gains start to get lost as you move to higher thresholds. At 14 knots, at least we're still better in 4.2 during the first 3 days. So there's a little bit of a diurnal thing going on there. Pretty even at longer ranges. For 23 knots, a modest gain still in the first 3 days, and then fairly even after that. For greater than 32 knots, equal MAE in the first 3 days, and kind of mixed beyond that. It's interesting that the wind stats do vary by region. They're not uniform across CONUS. And the good news here for this webinar is that the largest gains that last longer are in Eastern region. And that's pretty obvious here with MAE 4.2 is an improvement over 4.1, and it lasts all the way out to almost day 7. And you'll see pretty clearly that these are better results than you see in any other region. If I switch over to bias now, again, same idea. The bias looks amazing with all speeds grouped in together. But once we start to parse out the higher threshold, you'll see a greater than 14 knots. We have a slight low bias here that grows with time into a larger bias at longer ranges. But the magnitude of the low speed bias here in the first 3 days is actually less than the magnitude of the high speed bias in 4.1. But at longer ranges, certainly 4.1 is better. Interestingly, for greater than 23 knots, again, somewhat even here, just high in 4.1, low in 4.2. Pretty even, slightly worse in 4.2 out at longer ranges. And again, 32 knots, again, almost an equal magnitude of bias, just in opposite directions out to day 3, and then fairly even out beyond that. So what we need to note here is that while the deterministic winds in 4.2 have a notable low bias at higher speeds, part of the reason, excuse me, that we use the quantile mapping approach is that it allows us to generate a full set of calibrated percentile values. Having the larger sample size is great, but we're able to get a whole set of percentile products. So if the middle percentile speeds are too low at higher thresholds, and we're using the percentile mean here as we quote deterministic values. So if those middle percentile speeds are too low for those higher winds, in theory, the higher percentiles should provide useful information. So I'm going to show some stats now where we use the 75th percentile from 4.2. So now I'm going to have bias here, and for greater than 8, 14, 23, and 32 knots. The colors have changed. The dark blue here is 4.1, the ops. The light green is 4.2 percentile mean. The darker green is from 4.2, the 75th percentile. And what you'll see is for greater than 8 knots, Again, as you get out in time, the percentile mean has a low bias. The 75th percentile has a notable high bias. So you might find a perfect bias somewhere in between the roughly the 50th and 75th percentiles. As you go out to the higher thresholds, what you'll see is, especially as you get up to 23, the 75th percentile here looks pretty darn good in terms of bias throughout the range. It's even better than the ops 4.1 at the longer ranges. Again, also clear at greater than 32 knots. Again, 4.2 percentile mean is too low. Ops is too high. The 75th percentile from 4.2 is kind of in the middle. And then at the longer ranges, when both the ops and the percentile mean from 4.2 have a clear low bias, 75th percentile is a notable improvement. And a higher percentile than that would probably get you even closer to a quote perfect bias. If we look at gust stats in terms of NAE, again, same idea. The at the higher speeds, like the percentile mean from 4.2 for gust has a worse mean absolute error than ops, but again, that 75th percentile, especially at the longer ranges, is better than either the percentile mean or the current operational. Very clear, again, at greater than 32 knots. There's some clear value here in using the higher percentiles for some of these stronger wind cases. Here's the same thing for bias, and again, same idea. The higher percentiles in the shorter, at the lower thresholds are probably going to be too strong. But as you get to the higher gusts, you'll see here the bias for the 75th percentile, especially at longer ranges, is notably better than using the percentile mean from 4.2 or the ops 4.1. So a couple of the examples here. This was with big storm back in December, moving up the East Coast. These are errors. What we're doing here is we're comparing the forecasts from the ops and parallel. Parallel is the new 4.2 version, comparing them to Irma. So we're treating Irma as truth. We understand some of the limitations with doing that. And what you'll see is this is the case here. 24-hour forecast when the storm was just off the Carolinas. Here, a 15-hour forecast when it was off the Mid-Atlantic. And so 4.1 forecast on the left, 4.2 on the right. The darker reds here on the 4.1, even some of the purples, indicate some very large errors in the positive direction. So way too high sustained winds forecasted from 4.1. Notable improvement in both of these examples here in 4.2. Here's an example for gust. This is when that storm, again, was now moving up closer to New England. Here's the Irma. The strongest gusts were confined to the New England coast, particularly in the eastern half of Maine. And what you'll see is if you look overall throughout eastern region and even into the central region here in 4.1, we are a bit overdone, especially over most of New England here. There's way too much coverage of higher speeds to the Mid-Atlantic and especially over most of New England. And in 4.2, the notable improvement here with lower speeds over the Mid-Atlantic and New England. Now, the couple places where 4.2 isn't better, if you look here again over this part here of kind of part of the Maine coast, there's way too much. While there's way too much coverage of the higher gusts in 4.1, the gusts exceeding 50 knots are kept offshore in 4.2, so we're underdone here across most of Maine. And if you look closely over the higher terrain here of the Appalachians, where the Irma shows some quite strong gusts that are captured fairly well in 4.1. 4.2 deterministic here is notably underdone in that region. Here's another example. This is the January 8th storm along the coast. If you look at the sustained winds, here's Irma on the right. Again, way too much coverage or stronger wind speeds in 4.1, clearly overdone. 4.2, while a little bit underdone in a few areas, is a notable improvement. But it's a little bit more mixed for the gust. Again, 4.1 relative to Irma on the right is overdone in a good bit of this area, especially here in the mid-Atlantic. But 4.2 misses some of the higher end events, particularly here over upstate New York and over some of the higher terrain here of Northeast Pennsylvania and the Adirondacks. So again, I think 4.2 clearly better day to day for sustained winds. For gusts, better day to day, but it is at least the percentile mean is going to be low for the higher end events, and the higher end events, especially over higher terrain. Again, just to show you the range of products here for that case. This is another, sorry, back to the December case. We have the percentiles here. I'm plotting 5th, 10th, 30th, 50th, 70th, 90th, and 95th. For comparison, here's OPS 4.1, and here's Irma. Again, the 50th percentile does fairly well, but if you're looking to capture some of the stronger wind speeds, like offshore, clear issue. The Irma, we see here some of the issues with trying to use the Irma out of her water. That's certainly suspicious looking, but we assume that there are some stronger winds out here over the water. Again, the higher percentile values from the NBM 4.2 clearly do give you some of those higher wind speeds if that's what you're looking for. Here's gust percentiles. Again, same idea. There's some notably stronger gusts offshore. And again, the higher percentiles start to capture. Again, if we're looking to see some green here, well off the coast, those start to show up in the 70th percentile, especially in the 90th. And again, over the higher terrain, which we noted the percentile mean didn't do so well. You can see the Appalachian wind max starts to show up notably better here as you get to the higher percentiles. Similarly, just to show again the full range of products that we can generate from taking a quantile mapping approach. I've plotted here, these are probabilities of wind gusts at that time exceeding 22, 30, 34, 41, 48, and 56 knots. So again, even though we didn't, the quote deterministic value didn't have a great signal of the stronger winds along the Maine coast, you can see we did have over a 50% probability of greater than 41 knots. Again, I would like to have seen maybe a little bit higher probabilities in that area, but for the most part, this product behaves exactly as intended, and certainly shows some signals for the higher end events, and I think has a lot of purpose for IDSS efforts. So some long-winded thoughts here on winds in 4.2. Again, I think the sustained wind speed is significantly improved in 4.2. The winds in 4.1 have a notable high bias at shorter forecast lengths. We've had a number of forecasters say that the day-to-day winds in 4.1 have been unusable. And we clearly heard in the reviews that the winds in 4.2 are much more usable on a day-to-day basis. That said, we do in 4.2 now have a clear low bias for higher threshold, especially at longer forecast lengths. Again, higher percentiles may be a good alternative for those bigger events. And for the very high-end events, you probably have to go to the upper range of the percentiles, especially over higher terrain. Same is true for gusts. Low bias, especially at longer forecast lengths, but I think there's a lot of utility in the higher percentile data. As I noted, the stats show variation in error characteristics across regions, but the good news here for this audience is that the stats overall look best for Eastern region. Again, I think that here in 4.2, the changes made to address the low speed bias that we had in our initial version of 4.2 back in September were successful. We still have a low bias, but we improved it quite a bit over the original configuration that we had back at the start of last fall. There's still an overall low bias at higher thresholds, but it's not as large as previously seen. And again, the percentiles have utility in instances in which the deterministic value is too low. That said, we certainly realize that we still have a lot of work to do, and we are going to be working in the next version, 5.0, to continue to improve the wind products. I will note that over the SBN, we're only going to be sending the 10th, 50th, and 90th percentiles for wind and wind gust. But regional LDM feeds can hopefully be leveraged to provide additional percentiles. And we're working with the team that finds data to be recommended for removal from the SBN so that we can put in other stuff. And hopefully we'll be able to get more of the percentile data on the SBN sooner rather than later. Okay, I'm going to pivot to winter weather now. Talk about these lattice features. They're attributable to the individual model CDF or QPF CDFs that are used to generate the quantile mapping for snowfall amounts. And here's an example here on the lower left of the grid, very clear lattice. What we're doing now in 4.2 is that the individual model QPF CDFs are going to be smooth before we do the quantile mapping so that the snowfall probability distribution takes on a smoother appearance. Here's what that same grid looks like if you do that smoothing before the quantile mapping. And here's an example. I don't have a great example from the east, but here's an example in the upper Midwest, 4.1. You can see a very clear grid showing through here in the colors, especially here west of Duluth. There's still a little hint of it in 4.2, but it is notably improved. We have a number of changes to the SLR. Most notably, Dan Cobb has done a ton of work on a snowmelt function for, quote, warm snowfall, and we've put this in. Effectively, what we're trying to do here is allow for those events in which snow is falling at temperatures above freezing, but the rates are really high, and we can get some pretty decent snow accumulation at 33, 34 degrees. This allows that. In the old versions of the NBM, we were very inefficient at trying to accumulate snow at temperatures above freezing. So Dan Cobb has an SLR that has a melting adjustment. Again, it's going to allow snow to accumulate in certain environments. I don't have a lot of snow stats here because we found a bug in March that may have caused erroneously low QPF to get into our snow computations in 4.2. We caught it. It's fixed. There's no issues in 4.2, but it meant that our stats for a lot of the winter were not fully accurate. That said, what I'm going to show here, I'm going to show you what we do have, and note that the stats probably would look better if we had not had that bug in there. But my takeaways here, I think these themes overall apply for 2 inches and 4 inches, green 4.1, blue 4.2. For probability of detection, we have a slightly higher probability of detection in 4.2 at the first few days. But for false alarm rate, excuse me, we have a higher false alarm rate in 4.2. So a little bit of a trade-off here. Again, I don't have 100% confidence in the stats, but there is evidence that in 4.2, we've increased our probability of detection, but also slightly increased our false alarm rate. Here's a snowfall case I have from the Northeast. One of the other things that we're doing with SLR in 4.2 is that we are eliminating a 25% reduction of each member's SLR that's used in 4.1. In the past, again, the SLR for each member was chopped by 25%. The main purpose for that was that the QPF and especially in a number of the global members, has had a notable wet bias, and the snowfall was really, really high in the NBM. And this was kind of put in as a temporary adjustment factor to try and bring that down. But we introduced QPF quantile mapping a few versions back, and that has effectively taken care of that high bias in QPF that existed. The bottom line is we're overdue to remove that 25% reduction of each member's SLR. Probably could have done it a version ago, but we're doing it now, and I think this is going to be a plus. Here's a case from late season, pretty big event over New England, up to 2 feet here from south central Vermont up to northeastern Maine. And you can see the snowfall amounts are a bit higher here in 4.2. There's a number of things that go on. The melting factor is probably playing some role. But the elimination of that 25% reduction of SLR is likely playing at least some role here, and you can see amounts are increased in the correct corridor. Regarding that snow melt factor from Dan Cobb, real nice example here of a success of that. Here in the Mid-Atlantic, second week of December, we had a Sunday night, a strong front went through, temperatures crashed behind it, and precipitation lingered well behind the front pretty heavily, and the heavy rain turned to heavy snow, and we ended up with accumulation all the way to the bay here in Maryland, almost to the bay in the northern neck of Virginia, almost to the Pennsylvania-New Jersey border. In 4.1, the ops accumulating snow was confined to basically northwest of the I-95 corridor here in Maryland and Virginia. 4.2, again, it allows snow to accumulate in those marginal environments. Again, it snowed that night, temperatures about 34 or so. 4.2 correctly allowed accumulation to reach the bay and further east in Pennsylvania. Here's an example, though, where it didn't quite do what we had hoped. This in this modest snowfall here, Wisconsin and Michigan. Here's 4.1 and 4.2, and the coverage of the area of accumulation and the amounts were chopped down in 4.2. This was also a light event with marginal temperatures, but the forecasted rates were a little bit lighter. And this shows that the melting can actually be too aggressive sometimes in events with marginal temperatures and light rates. So Dan Cobb has done some work to address that. It's way too late to get it in to 4.2, but Forecast Builder already has an update to the snow melt factor to address this issue. So while it won't show up in the direct NBM output, an adjustment can be made in Forecast Builder. Okay, blocky winter fields. And here's an example on the right. This is a probability of snowfall forecast, very clear blockiness. So this is not a new issue in the NBM. It's been there for a while. But this past fall, once we started getting into the new winter season in early October, we started hearing about this issue again in the VLab forum. It was most pronounced around day 3. What we determined was that this was driven by the NAM parent. That's the 12-kilometer, not the NAM nest. At day 3, it gets about 15% weighting in 4.1, and even higher if other inputs are unavailable. Just for comparison, the GFS gets a 3% weighting. So the parent NAM input is not downscaled in 4.1. It's worth noting neither is the GFS in 4.1. This was identified as the primary cause of the blockiness. So unfortunately, the parent NAM is not part of the quantile mapped QPF. So we didn't have a downscaled QPF for the NAM that we could use. We did have it for the GFS, and we're using it now in 4.2, but we didn't have it for the NAM, and it would have taken several months to generate So we didn't really have that option. So we talked to our SAG, and they recommended that we remove the parent NAM from the winter suite. And again, not the NAM nest, but we're taking out the parent NAM uh, to try and address the blocky features. Again, for the GFS, we already had a downscale precip that we could swap in. Didn't have it for the NAM, couldn't create it in time. So we said, let's just pull out the NAM. And again, I said that we took time in the fall to correct the wind issues. That gave us an opportunity to correct issues like this. So even though this upgrade is later than we wanted, one of the benefits is by taking the time to get the winds right, we were able to address an issue like this. So here's what we're doing now in terms of the winter weighting. This is Ops 4.1, shows the model inputs here in the left column, forecast hours across the top, and the weights. You can see, as we mentioned, the parent NAM gets weighted only a little bit early on, but that grows here. As the other cams drop out and you get into that day 2, 3 time period, all we have in terms of the cams is the NAM nest and FV3 high-res window, and those are gone by 60 hours. So the NAM gets 15% weighting. The rest goes to the SHREF, GFS, and then the GEFs and European ensemble members. What we did is, again, we zeroed out the NAM, not using it anymore in the winter suite. At day 2, we redistributed those weights to the GFS, NAM nest, and high-res window. And at day 3, we distributed those weights just a little bit more to the GFS. The big bulk of the weights went to the 30 GEFs and 50 European members. And again, the removal, this has been very successful. Here's an example from upstate New York in 4.1. This is a probability of snow, even across in Vermont. Pretty much all through here, you can see it. It's just most notable here over New York. Very blocky. Looks like an old 80s video game in some ways here in Ops. Notably smoother field here in 4.2. Another thing that we are changing in 4.2 is we are computing now a downscaled wet bulb temperature. What we're doing is we are first computing, we have a temperature, a raw temperature, and then we compute a downscale temperature. And what we do is we subtract. So we come up with a delta, the difference between the non-downscale temp and the downscale temperature. And then what we do is we have a non-downscaled wet bulb, which is either from the model directly or computed. And we apply that delta to it. We're basically assuming the difference between downscale temperature and non-downscale temperature is going to be about the same as the difference between the non-downscale wet bulb temperature and the downscale wet bulb. So again, we subtract that delta from the wet bulb temperature to get a downscaled wet bulb temperature. This is not a perfect approximation, but Dan Cobb, again, done a lot of work in this area and was pretty convinced that this should be a reasonably accurate estimate. We apply it only to the European ensemble, the GEFs, and the SHREF ensemble. So again, only to the coarser model resolutions. And you can see an example here of this is a non-downscaled wet bulb temperature here at the top. And this is what the downscale looks like on the bottom. So non-downscaled on top, downscaled on the bottom. Much better representation of topography and very helpful in freezing rain events. Another thing that we were able to address this fall by taking a little bit more time with this upgrade was an issue that was pointed out to us with high probabilities of freezing rain in events where they weren't warranted. So here's an example from Ops. This is a probability of freezing rain, and certainly values here up in the 20s and 30s would get any forecaster's attention. And no freezing rain actually occurred. So we looked at the inputs, and I'll show a few of them here. It was clearly driven by the two high-res window ARWs, not from the HER, not from the FV3 high-res window, a little bit from the NAM Nest, but largely from these two high-res window ARWs. The issue is in those models when in the post processor, when a determination is made whether to compute a p-type, it's driven by an instantaneous precip rate. If that exceeds a particular threshold, compute a p-type. If not, do not. And that threshold for the two ARWs is much lower than it is for the other inputs. And we certainly want to capture trace events, but this threshold was set really effectively even below trace events. So we decided to zero out high-res window ARW precip type if the hourly QPF was less than 0.01. And what that does is we go from upper left, this forecast that I showed, to what we get in 4.2. You can see these little bits of blockiness lines up perfectly with what the NAM Nest is showing. Again, here's the QPF for that time. There's no QPF forecasted. There's no observed freezing drizzle. You have to take my word for it on these tiny maps. So this is a notable improvement, reducing a pretty big false alarm in terms of probability of freezing rain. We're confident that this change reduces the freezing drizzle footprint. We agree, the SAG agrees, this is an overall improvement. The NAM Nest covers the freezing drizzle threats fairly well. We don't want to wipe it out in situations where there really is a threat, but we think the NAM Nest has it, even though the coverage is a little bit spotty. And this change was noted as a positive by several evaluators. Quick note here on the mixing height. What we're doing, so the downscaling for mixing height, or the bias correction, I should say, is being done using the RAP analysis. And that's a 13-kilometer analysis. So you're not going to represent terrain very well. So what we're doing now is we're incorporating the difference between the RAP and the IRMA unified terrain height when we compute mixing height. Again, much more accurate depiction over terrain. If you look at the terrain difference between the IRMA unified terrain and the RAP, pretty dramatic over the higher terrain, most notable in the west, but certainly over the higher terrain of the east as well. I wanted to pick an example here relevant for Eastern region. My examples in the West are much more dramatic, but picked an example here from the What's Up viewer, 4.1 on the left, 4.2 on the right. It's not the most dramatic case, but you can see more evidence of the terrain here over Vermont, over parts of the Catskills and Adirondacks, the mountains of central Pennsylvania. The higher terrain here of the Appalachian shows up. It's subtle. The scale here is unbelievably large. I probably should have redrawn this with a reduced scale, but again, you get the idea that there's a clear impact here from bias correcting now to a higher resolution topography. All right. So that covers what we're doing in 4.2. Even though we're still haven't quite gotten this into operations yet, we are already started work on 5.0, which is targeted for late summer of 2025. We have a pretty long list here of things we want to do. The top group here is mostly products and then more science, and the lower group, what we want to do is we want to extend hourly products from 36 to 48 hours. We're going to use quantile mapping to generate probabilistic fire weather elements and probabilistic wave products. We're going to add precipitable water and lifted index. We're going to add direction and gust to tropical cyclone feature matched wind products. Then in terms of science, we're going to continue to work on improving the winds over land, and we're going to work on improving them over water. We know we have severe limitations with our wind speeds over water due to the low bias of the RTMA IRMA and some artifacts in the RTMA IRMA. So we're looking at ways to make our wins better. We're going to use a long archive of IRMA data to do bias correction instead of just the most recent period. We're planning to use a single reanalysis source for QPF and make other QPF improvements. We want to make QPF and snowfall output more consistent. You get situations where you get 4 inches of snow but like 0 QPF. We need to make those more consistent, and that is a priority. It's been a long haul to try and get higher resolution ECM WF data into the NBM. NCO is finally going to be pulling it in this summer, and we are ready and waiting to start testing it. We have to prepare for model retirements. In a couple of years, the production suite is going to look very different, and a lot of our inputs are going to have to change. In theory, the Shref, NAM, and high-res windows won't exist in a couple of years. RFS hopefully will. 3D RTMA is going to replace RTMA IRMA in a year or so. And the problem is we don't know exactly what the plans are, timelines, exact choices for production suite changes. So we're trying to be flexible, but we know we have to make some pretty big, significant changes to when the production suite changes finally do occur. We'd like to remove low skill and unreliable inputs. Bias correction can only do so much. We're trying to gather evidence for each parameter, like which inputs really hurt us more than they help us. Dave Rudak, who's joined us here this morning, is doing some awesome work to calibrate 24, 48, and 72-hour snow exceedances. So you'll get, calibrated snow exceedances for 24, 48, and 72-hour periods. We want to revisit the inputs to the quantile map QPF, and we need to continue to improve mixing height. Very, very general, broad look at plans beyond 2025 in NBM. We'd like to achieve greater consistency across the NBM elements. We're going to continue to add probabilistic products in support of probabilistic IDSS. We're going to build the next generation MDL post-processing system. It starts with the blend, but incorporates the LAMP and MOS products. In theory, in a few years, the LAMP and MOS will not be standalone products. They'll all be coming out of one MDL system. We're going to explore AI ML approaches, especially for leveraging use of long reforecast data sets. That will allow us to bias correct based on regimes, synoptic patterns, things like that. And I think will be a big plus for NBM. I know there was a big push here from Eastern Region to get a little bit of information about documentation and resources for learning more about NBM. So I put a few slides together to end with that. This is our primary NBM documentation page. There's a link here. This is what it looks like. We have here for 4.2 development, we have links to various presentations that will be of use. I'll talk a little bit about some of these other things, but there's training modules, technical notices. There's our VLab community, which we think is a great place for resources. We have our VLab forum, where there's a lot of great information exchanged in there. My team is pretty excellent at responding to questions in there. And if you're not subscribed, you should be. We have added some quote best practices for VLab forum posts, which I believe that Justin Arnott has shared with Eastern Region, that we're just trying to, things that we're asking for that will help us most efficiently answer your questions. On that documentation page, there's a link to individual model cycle inputs per NBM cycle issuance. And that page, I've taken a few screenshots here and pasted them together. This shows for each NBM cycle all of the possible inputs. Doesn't mean that each is going into each parameter, but these are all of the possible inputs and the resolution. And for each cycle of the NBM, it shows which cycle of each of those inputs are being used. And you'll see again, it takes time for new data to become available. For example, for the European, it comes in notably late. Like the 0Z European deterministic doesn't get in to the NBM until the 8Z cycle, and it's cut off here, but the doesn't get in for the Euro ensemble until I think it's either 9 or 10Z. So this is a way to see again which cycles of which models get into which NBM cycles. There's a link here to this description of field selected algorithms for NBM. This is a document that we put together last year with the AFS 11. A lot of good information in there, includes information about quantile mapping, how percentiles are computed, weighting, product timing, lots of information about how different products are computed, a full section how we compute our winter products, sources of biases. This is a really good document that, again, answers a lot of questions that you may have about the inner workings of the NBM. Something new here that's coming out here with the 4.2 implementation. This is a new weather elements content page. And this is work that Brian Haynes and Greg Leone in our division have done. Contains a description of weighting and region information for surface, aviation, fire, winter, and marine elements. And then for upper air as well, where it has pressure level info instead of region. Again, you can see it's just a snapshot here. It explains what each element is. Shows for like CONUS, Alaska, Puerto Rico, Hawaii, Guam, and Oceanic, whether it's available for that region. And then if you, these arrows that point down, if you click on one of those arrows, it highlights the cell. And like here from NT, you get weighting information, a link to which models are used in the NBM and models used in the latest NBM run. Here's the same thing for QPF, where the difference here, you can see it has a link to what the expert weights are. So again, a lot of information there to help you understand what's going in to each computation. And we also have this brand new dashboard, and you get linked to it if you go to the models used in the latest NBM run. Here keeps, I think, about a week's worth or so, where if you click, you get to choose date and cycle, region, weather elements, and projection. So here on the left column, we've chosen for this cycle, it's 21Z on September 14th for CONUS, maximum temperature, 90 hours. The blue here is going to indicate which models were expected and then used, and the red indicates where it was expected and not used. So and there's a few that are listed here where it was not expected and not used. But the bottom line is you can see, again, if there's a 1 and a 1, that means it should have been there and it was. If it's red, that means it was expected, but it was, for whatever reason, it did not get into the forecast for that particular element. Here in the middle, an example, we're doing surface Cape, a 12-hour forecast. And again, 2 of the models here were not available. And here's just what you see if you click on the projection option. The light areas indicate where we do have info for that forecast hour, and the red is the current selection. So we think this is going to be a really valuable tool, because if you say, you know what, wow, that day 4 snowfall forecast, man, the Euro is going for a big snowstorm here and ensemble. I don't understand why I'm not seeing a reflection of that in the NBM. Go see, did the European ensemble make it in to that particular cycle? Check with the info back here with the expected cycles. Like, should that European cycle have gotten in for that particular cycle of the NBM? The point is, there's a lot of information now that can help forecasters determine what should have gotten in, what did get in. I think it's, again, going to be really valuable to help understand what you're seeing in the NBM forecasts. And with that, I will stop. I think we have plenty of time for questions for me and for Dave. Let me just, before we end it here, Dave Rudak, anything that you would like to add here about the upgrade or documentation?
Really, no, you covered it beautifully, Jeff. I think it was pretty comprehensive. So
Right, thanks.
I really got nothing to add.
Thanks, Dave. So Jordan, Paul, however you want to open it up here, we are ready to answer questions.
Well, first I want to say thank you, Jeff, for that really great comprehensive presentation. There's a lot of ground covered, so not to address everything you spoke to, but just a couple of quick questions from my own perspective. So the NBM weather element table you showed at the end, that is available now or will be available soon? That's question one. And then will it also be on the documentation VLab page as well?
So the elements page is live already. That's but the one that shows whether a particular model made it into a particular cycle of the NBM, that will go live with implementation. And yes, we will add relevant links on our pages, and we'll advertise them in the VLab forum as well.
Perfect. Thank you. Well, this is a perfect segue in terms of talking about resources. So for everyone's context of how this all, initiated, of course, we have interest regionally to have this conversation, but lead met Paul Fitzsimmons, who is on today, and thank you for working with me on this, Paul, in association with his class project, wanted to take a deeper dive into potential regional collaboration and best practice initiation and other topics between those two points of interest. So at this point, I'm going to turn it over to Paul to give a background on the additional reasons why we're here and what more conversation we want to have this morning. So Paul, the floor is yours.
Thank you, Jordan. Yeah. So this all kind of got started as I was involved in the Eastern Region class program and kind of thinking about what would be a good project, a good kind of regional thing that I could do that might be helpful. So the thinking here was that the NBM is obviously a big topic in the NWS these days. And I wanted to see if we could get some kind of conversations going about the NBM and usage and kind of revealing what's in the black box, because I think that many forecasters today are, we are kind of seeing the NBM as a little bit of a black box sometimes, and that makes it difficult to sometimes fully understand what's going on. And if we can't fully understand what's going on, then that makes it harder to, be as comfortable giving the kind of in-depth IDSS we want to give. So yeah, that's kind of what got this all started. Let's kind of transition here. Entire screen. So yeah, I mean, basically the idea here, what we wanted to do is have a series of webinars, kind of talking about some of this kind of stuff, and also we had to kind of get this all started off. One of the things we did was we sent out a survey for the offices, and I'm gonna bring that up over here actually, many of you are probably aware of this. This at least went out to the science officers, but we asked a bunch of questions about the national blended models and how the different offices were using the NBM, and then came up with some overall points from that. And one of the questions we asked in the office survey that went out was, what are some of the best practices your office has found to leverage the NBM in both the forecast process and probabilistic messaging to core partners? And what we found from those responses is we kind of wanted to parse them into different categories and for different things. And one of them being offices that were using the NBM as the basis for the days 1 through 3 forecast. Offices that were using it as the basis for the days 4 through 7 forecast. And we found that, we could categorize that into 4 answers based on the feedback we were getting, which was mainly just like in a narrative form. We had some that said yes. We had some that said sometimes. And then there was obviously the option of anyone that explicitly said no. But we did not actually get any no's for most of these questions from these, from the survey. But then there was another category, which we call undetermined from response given, which I want to emphasize does not mean no. It just means we could not determine that from the response given. So what we found that was interesting and encouraging is that, well, if we look at days 4 through 7, actually, we had 4 of the 13 responses we got in the survey saying yes. We had no offices that were saying sometimes. We had no offices that were saying no. We had 9 that were really not determined from the response given, which I think in most cases the answer is probably going to still be yes on that. But we go kind of beyond and start to look at some of the more interesting questions. We asked where we wanted to get feedback on what offices were using the NBM percentiles for collaboration and forecasting. We had 8 of the 13 responses from the Eastern region offices saying that they were using it for this. We had nobody say no, and we had 5 that were undetermined from responses, undetermined from the response given. Similar results for offices using the NBM probabilities and percentile data for messaging and IDSS. We had 7 yeses. We had 5 undetermined from responses. Only 1 no, though. So we did actually get a no, basically saying that that office didn't feel that the users fully understood the data, so they weren't using that. I'm going to kind of quickly go down, and then we can get into the questions here, because this is going to segue us into the more discussion part of this. We asked in question number 2, what are some repeated examples of NBM issues your office has encountered within the last year? And how did your office go about resolving them to address GFE-related items or local IDSS? And by far, and Jeff did an excellent job actually, talking about this today. By far, the biggest thing we found is that offices were not happy with the wins in NBM 4.1. Found them too high, especially at night. And there was some interesting things that came up though about how offices were going about correcting this bias. One of the examples being Caribou and Gray collaborating on making a local tool that automatically blended 80% of the 10th percentile. QPF obviously was another big one, especially with lake effect snow, especially with light QPF events, especially with QPF being too washed out, quote unquote, or in the middle of the road when you have extreme events. Dew point bombs were another thing. We all know about that, I think. I think that's a thing pretty much region-wide in Eastern region. Cold air damming is obviously another issue. And then kind of going through this quickly, get to the last thing that I think becomes one of the biggest things in operations. Not a lot of offices actually mention this, but we have what I would call the lag effect, where the NBM that we're expected to kind of be using as the basis for our forecast is going to be lagging the latest deterministic guidance, which When things are changing, that obviously that can be a big issue, especially if, I noticed it just this past week. It's like in that question, it's like, what do you go with? So we wanted to at this point kind of open it up to any questions anyone had on anything they've seen so far today. If not, we were going to kind of ask a couple prompter questions, but we wanted to open up if anybody had any questions. I guess we'll start again. The question I would have, and again, anyone can feel free to jump in on this, is there anything specifically about the NBM you feel like a particular parameter, for example, you feel you don't understand, or that gives you a more than typical amount of trouble when it comes to either making the forecast, providing IDSS, or preparing the messaging? I guess everybody is happy with the NBM. Yes, Brian.
Hi. Yeah, I guess a few things with the NBM. Like, do we notice? I know we sent you that feedback. Just some of the, we have like the philosophy, I guess, of looking for targets of opportunity. But then again, like one of the things I struggle with is there's always a target of opportunity. Like dew points are tricky, particularly in fire weather situations with like dew point bombs and stuff like that. So like usually anytime there's like hazardous weather, I'm trying to add some kind of value to it. But I guess like to your question, I guess like dew points would be one of concern that I have, particularly in well mixed environments. And then of course, you brought up the wind with the 4.1. I think the 4.2 is doing better in my opinion, at least anecdotally, looking at it. But those are kind of the main things that I've noticed. And then sky cover. I guess we all know about like the 57% that gets plastered out there. So like that becomes a little bit of an issue, particularly in near and short term when you're tweaking the sky grids. But those are kind of the three elements that we've noticed that we edit on I don't want to say on a consistent basis, but certainly when there's potential for fire conditions and we're doing spot requests and stuff like that.
Yeah. Hey, Brian. Good to see you. Yeah, as you noted, I'm not sure when you joined in here, but we're very confident that the day-to-day wins in 4.2 are notably improved, because all we heard after 4.1 went in was like every day the wins have to be edited because they're way too strong. And again, we feel pretty good on the day-to-day basis that is notably improved in 4.2. The dew points you mentioned, boy, that's it's a tough one, and completely understand your challenges there. Besides the fact that I would say overall, a lot of the guidance is not too great with dew points. In a lot of ways, there's limited what we can do. In theory, bias correction should help there, but the challenge is because right now we're only going back and looking at the recent 90 days. It varies a little bit element to element. Like here we're in now to a spring where we're starting to green up and get evaporation. We're still bias correcting off of data from the end of winter, and the bias, what the bias was in early March probably isn't what it is today. So that's a challenge with the current bias correction. But that's where looking at older RTMA IRMA data covering multiple years and covering both sides of a period, like for today, instead of just looking back at a few months, you look on either side of the date over multiple years. That should help. I don't want to be too aggressive on that, but it should help at least some in that area. Ultimately, I think again, AI ML for pattern recognition, like how you bias correct dew points in southerly winds, probably going to be different, at least here in the mid-Atlantic. Southerly winds is going to differ from how you bias correct it with northwesterly winds. So I think that's the area that we're going to, be heading, because we certainly understand the challenges there. And boy, sky cover is its own, set of nightmares. But again, that's something, we're certainly aware of and looking for solutions.
Yeah, thanks, Jeff and Paul. Yeah, those are the main elements that I've noticed. Yeah, I think pop's getting much better. I guess I will say, like, sometimes maybe when it's drawing a lot of the cams in, it can be very like sporadic, if that makes sense. And sometimes I find myself trying to smooth it out, and I don't know if that's even if what I'm doing is even the right thing to do, because but like you're trying to have a theme of say scattered showers or thunderstorms, but you have like the popcorn a little bit there. But that's I don't know.
Yeah, this is the short range precip pops. This is something we're struggling with because we feel like we need to go more heavily towards the cams if we want to capture the higher end rainfall events. But as you said, you tend to get, here and there kind of thing. And maybe we need, maybe we need some kind of neighborhood products. That's something we've talked about, but then it raises questions. Do we want like separate non-neighborhood and neighborhood products? This is the stuff that we're struggling with because there's already 10 trillion NBM products, and we're hesitant to add 10 trillion more. But there's also the one size fits all on some of these events also doesn't work very well. So this is what we're grappling with, working with our science advisory group. But Dave, do you want to add anything there to some of those challenges? I guess he does not.
Again, no, I mean, again, you covered it well. I mean, it's, bias correction based on regime is, well, it certainly will help. I just practically to be able to go back and identify regimes and then use those regimes, and then what happens when you transition to another regime? What do you do with the transition? And is that next regime really legit? And then you're going to bias correct the wrong way. I mean, there's a lot of complicated things here. And well, I'm not as optimistic as Jeff about doing that, because I know that it takes a lot of data and it just takes a lot of time. I would more like to focus on the hazards coming up. Certainly more in the short term, because you've probably got more information on that, and to some extent just be a little less uncertain about the stuff in the extended range, but obviously give some credence to it. So where you can, I don't want to bite off more than we can chew and pretend that at day 7 we can nail the winds at a couple of grid points. I mean, except for maybe Mount Washington, because that's just like thunderstorms in July. But beyond that, I am kind of a little apprehensive about certain things. So if the NBM is supposed to be a starting point, I don't know that it really will ever be the ending point, to be honest with you. There always is, like you said, Brian, you're going to need somebody over the loop and somebody you're going to play with the grids, and a little bit, you would want them, the deterministic grids, to be consistent with your probability space, I would suspect. So you're going to need to play those games. So, we're just going to look at target opportunities, really, but I can't say we're going to solve every problem, the weather problems that there are. I'll leave it to the modelers to help us out first. That's my take on it. I'm just being brutally honest.
Yeah. I mean, as Dave notes, we're expected to be, the day-to-day, basis for the NDFD, but we're also supposed to play a big role in probabilistic IDSS, which are two very different ends of the spectrum. And trying to come up with products to fit all of that is really tough. And again, we have a very talented group here in our division, but sometimes the expectations do outpace the science.
I wanted to speak just a little bit to the QPF and snowfall. Because again, that was something that offices raised as a big thing, especially out towards like day 2, day 3. Has there been any consideration into like morphing towards like maybe like a probability matched mean type of thing with QPF that might make some of those that might improve some of that for like the higher end events?
Yeah, we've actually had discussions about that within the last week, literally
Okay.
on that. I think that the question is, well, our QPF group, we're actually playing around with a methodology called coalescence, which does some of the same things as probability matched means, but certainly something to restore amplitude from individual solutions when the locations are scattered is something we want to look in. We're going to look into. The challenge is, I don't think we just do like a 1-for-1 replacement with some kind of probability matched mean product with our QPF stuff. Maybe they're a separate set of products. I don't think we know yet. I look at like the HREF. The HREF has mean, probability matched mean, local probability matched mean. For certain fields, it has ensemble agreement scale means. So, they put out multiple products for, different, possible, parts of the spectrum to cover. And I don't know that we can just put out a single product that's going to meet everyone's needs, because probability matched mean, if we just say replaced QPF with that, I think it would do awesome on the high end events. But I suspect we'd suffer day to day with a pretty darn high wet bias. So I said, these are the things, again, we're trying to weigh and figure out. Again, do we need new products? Well, we don't know. We don't have all the answers yet, but you're spot on when you say we do need a way to, capture some of these higher end, especially short-term events.
Thank you. Thank you. Yeah, and I think the other thing that just kind of thinking about as we were talking, the 57% sky cover was another interesting one. Is I rarely see forecasters just go with that. Usually it's not that we're not using the NBM for that, but we're often blending it with something and doing a lot of smoothing, because I think there's just a lot of like, okay, well, that's so random, 57%, because you can have that right next to like a 0%. And it's like, I think a lot of forecasters just kind of question that look, and they're like, why?
Yeah, understood. There's no good way to blend that stuff. Go ahead, Dave.
I was saying, I mean, we removed that for 4.2.
Okay. Okay.
The 57, I mean, it was just to keep consistent with the lamp ceiling height.
Okay.
That's
Got it.
why the number was there. So you either broken or overcast. We don't know what, but we just wanted to at least be consistent for aviation purposes. I mean, yeah, it did look kind of weird with a huge gradient sometimes. So people said they didn't like it. So we said, okay. It was a simple Fortran, comment something out. It wasn't a big deal, but again, it was a request that we had for 4.1. So, people took stock of it, then eventually looked at it and said no. So we reverted back. So there is an inconsistency between sky cover and lamp ceiling height, which is, we use directly lamp. That's what it is. We don't massage anything for the ceiling height or visibility. I mean, for the first, I think it's 26 hours is lamp. So, except for over the water, I believe now for 4.2, we use the wrap for, I think after 18 hours, is that, Jeff?
Yeah, we changed it. I don't remember the details.
And I think it's something like that. But by and large, it's over the land, it's all lamp.
Okay. To your point, again, this all gets complicated because, yeah, you did that to remain consistent, that's a good thing. But it causes that issue, and then now you're not necessarily going to be consistent. So yeah, no, I understand. It's a difficult balancing act. The other open-ended question that kind of we wanted to see if anybody here had today was just like, is there anything specifically that anybody thinks that would really help as we go forward with this? Because again, I think the biggest thing in the field, and Jordan and I had this conversation via email last week, is just, you know, where the idea, of course, is, you know, probabilistic forecasting, probabilistic IDSS. But in the old days, you know, when we were just using the deterministic models, forecasters could have a very deep understanding of how the models were trending, what this one was showing, what this one was showing, and kind of really have in their head all the different pieces. But again, with the NBM, there's so much going on under the hood. And as the job is transitioning to obviously do a lot of IDSS, I think there's a fear that, you know, if we don't understand what's going on and we're just saying, well, the NBM has a 30% chance of this, I don't know why, but, you know, that's the fear forecasters have, I think, is just that, you know, the fact that it's a black box, the fact that they're not going to be able to add that high quality of really in-depth IDSS to the partners. So yeah, the question, I guess, is what might help anyone on this call who's kind of thinking about that issue or has been thinking about that. Is there any suggestions you guys have to help that?
I mean, I'll just jump in and say again, I think our new elements and dashboard pages are going to be very helpful in that regard, because yeah, I get it. It's like the POP 12 is 40%. You know, where's that coming from?
Right, exactly.
This is going to allow people to understand. I think the one thing, being somewhat new in this position, you know, I had to learn a lot about how the NBM worked. You know, I thought I knew a fair amount when I got to MDL. Turned out I didn't, and you know, I had a lot to learn. That the one starting point for understanding the NBM that I think is great for everyone is if the field, for the basic premise here is if a parameter has an analysis that's usable, then we bias correct to that analysis. If it does not, then we use expert weighting. That's again a great way, I think, that's helped me, you know, sort things out right off the bat. Like for POP, you don't have an analysis for that, so you'd use an expert weighting system. Cool. For temperature, you have a good RTMA. There's limitations analysis, so we bias correct to that. So I think that's a really good starting point. And then if you want to see what the weighting is for a particular one that's, say, expert weighted, that table will tell you that. We have the like the what's up viewer show, you know, the bias correction, you know, it weights based on, you know, performance over the past few months. You know, day to day in the what's up viewer, you can see what the weighting for the bias corrected stuff is. So I think there's things there that that document that we developed with AFS 11 that I referenced here in the presentation. There's some really good information in that. So yeah, Dave, that point and click as well. So
yeah, I've seen that. You know, I've always scratched my head and seen that in the certainly in the extended, mostly sunny with a chance of thunderstorms. So I don't know what the heck that means. I mean, yeah, when there's a thunderstorm over me, it'll probably be cloudy. But other than that, you know, it won't be. So, I mean, I don't know that it's a complete contradiction of what you're actually giving to the public right now. So I don't know why our guidance would necessarily have to differ. I understand your point and maybe help you make that decision. But, I mean, we wouldn't want to make it cloudy the whole day either.
Yeah.
And just back on your other point, Paul, I just, you know, well, I understand the need to know what the underlying models are doing, and a forecaster, to me, that's the first thing you need to do. I would think you get on shift is look at all the different guidance and kind of massage it in your head a bit. But you got to understand when you go into AI and you go into deep learning, you can throw all that out because you'll never understand why he's doing it. So, you know, the forecaster is just going to have to stop asking questions at that point if they really want AI, because we won't be able to explain it. It just is the way it is in terms of training the data. So it's kind of like can't have your cake and eat it too. You know, if you want there's going to have to be a trust factor to some extent. Of course, verify, but you know, at some point, if assuming things verify okay, well, then they're just, that mindset and culture is going to have to shift, because there's no other way to do it. You can't have both.
And that's true for the models too. As more and more of the models are going to an AI approach, it's going to be harder for forecasters to diagnose what's coming directly out of the models and not besides the post processing too. So that's a challenge throughout the forecast process.
Jordan?
Yeah, so I just want to jump in and highlight one of the things that I'd say the most questions I get on an average week are about the different components and the timing, and when's coming in when. And I know I'm backtracking to a previous part of this conversation, but I'm doing that because I do want to highlight these two new resources for those that came on late in the presentation, that you have developed, Jeff and Dave, and MDL. These two new, please correct me if I'm saying it incorrectly, the weather element context table or content table as one piece, and that close enough. Yeah. And then the other piece being the tables that you've had actually in VLab folders, but now you have in that link on the documentation page specifying the forecast guidance that's coming in at different times for different NBM runs. There are a lot of answers in these resources to a lot of the big questions that'll come out, like when is this coming out, what guidance is coming into this model when, to give everyone better insights. And of course there'll be other questions we can't necessarily predict and answer as they come about, but there are some good resources. And the fact that the MDL team is adding these resources in the coming months to the VLab documentation page, and we'll of course remind all of you regionally as well about these resources once they go live. They are live once they're added to the corresponding online VLab resources. They're useful and they can be helpful to answer questions. So, and the most important part of this whole conversation is they'll all be in one place, so you won't have to go in different places. And that's another factor of all this. So kudos to your team, and hopefully I didn't say any of that incorrectly. So feel free to correct me if I'm wrong.
Minor correction, but again, I think you hit the key points there, and I appreciate the kind words. The page that shows like for which NBM cycle, which cycles of various inputs go in, that's been out there actually for a long time, and we just need to make sure people are aware that it's there. The other thing that's new is the dashboard, which shows for a particular cycle. Let me back up. The page that we just referenced, shows what's expected, to get in. The dashboard now will show you if it actually did, because you think it's an automatic thing, but some data doesn't come in reliably. Some stuff comes in late. The NBM doesn't wait for stuff. It runs with what's there, and if it's not there, it moves on. And the European ensemble data is late coming in. We'll try again next hour to use it. So those things do happen. And again, the dashboard is very useful in that regard for seeing what actually got into a cycle, especially if you see something that doesn't seem to jive with what you were expecting to see.
Yeah, I mean, also it is really a one-stop shop, even if you just want to ignore the live data, but it tells you what models just what models you would normally see for that weather element, and what cycle that model is, what model cycles used, and what particular projection for that NBM projection is used. So if you just even wanted a quick reference, and you don't care whether it got in or didn't, you could always just look at that dashboard without looking at any documentation. So it's a pretty handy thing, and we know we've been lacking for that for a long time, but we made it a priority this time. So
Thank you.
All there, and it's good.
And I just want to stress, everyone here should be subscribed to the NBM VLab forum, because so many questions get answered in there. And again, our group puts a lot of effort into providing thorough responses there, and it's a great source of information.
Thank you. Yeah. And to your point that you raised earlier, Dave, no, I agree. It's the whole thing about, like, as we go deeper into AI and, more complex numerical modeling methods and all that. We're not going to be able to absolutely understand everything, but I think the challenge is that until the models, and they may never be this way, but until they're perfect, we're going to have to be able to find a way to know when we need to sort of adjust, the messaging a little bit because the model might be off course. So that is going to be an ongoing challenge, is just knowing, okay, well, the NBM might be going a little astray here, and here's why. Otherwise, if you're not necessarily knowing exactly everything that's going on, you kind of have to trust it, and you might be trusting it when you shouldn't trust it in rare cases.
Well, that's why you got forecaster over the loop. At least sometimes use your common sense. That's all you can say. And if you're wrong, well, you're wrong. Until you use AI next time. But yeah, I understand the challenges, but even forgetting about that, I mean, the latency of some of the products inside the NBM itself is a concern, because sometimes you'll get a newer GFS, you'll see a quick look of the deterministic, and it may be a little while until the NBM, absorbs that data and actually does something with it. So the messages, might need to change quickly. It kind of bothers me that that's the way the timing is right now, because you're looking sometimes at two different worlds, and then what do? I don't have an answer. You know what I mean?
I agree. And, I don't know if this is the right answer, but I am going to just throw something out there. Having been in this NBM world now for several years and seeing that a lot, one thing that I think is, I've kind of tended to learn is that when you have that problem in the long range, days 4 through 7, and you get that new deterministic guidance that's contradicting the NBM, it's probably good to still stay closer to the NBM, because it's dealing with multiple cycles. It has the ensembles. When you're getting into day 1, day 2, day 3, and you're consistently seeing that the NBM is lagging behind a trend, I think at that point you can sort of start to hedge. Again, I know we're not trying to find the perfect. We're moving into a probabilistic world, but you can start to nudge the probabilities maybe away from what the NBM is showing towards what the deterministic trends are showing. I don't know if there's any validity to that, but that's just anecdotally.
If you want an example, Paul, I forget if it was January or February, there was an event where the models had all locked in on a snowstorm across New England. I mean, it was like Boston, I think, was starting to close things, and ended up, this is at fairly short ranges. And there was a last minute adjustment south in all the guidance. Well, the NBM was slow to join the party in terms of really nailing New England with the high probabilities, but then it did, and then it took some time then to get them out of there after when the models all at the very last minute moved south. The NBM moved south too, but again, there was a lag there. So both ends there, we were correctly slow to join the rest of the group when they started, quote, locking in. But then when they all changed their mind, it took time to get it out of there. And but again, people were complaining about the probabilities in the NBM for that case. Every ensemble member, every deterministic system, had a huge event for New England at like day 2. And there's no way that we can undo that with our methodology right now.
Well, right. And like you're saying, in that case, what it sounds like again is that the NBM is going to always lag a little bit behind.
Yep.
But that's not necessarily, the end of the world if we know that that's probably going to be the case. And, again, don't mean to segue too much, but of course, we're probably going to be wrapping this up soon, but we want to have future webinars where we're talking about some of this kind of thing, to those who are on here, best practices for dealing with cases like that, when you have this contradiction in deterministic guidance versus the NBM. And you're right, Jeff and Dave, you're never going to be able to fix the models to make this perfect, but if you can be aware of when there's those contradictions, when it might be better to stray one way or kind of lean one way or the other, I I think those are important discussions to have in the future.
I think also, and we're thinking about this is in terms of QPF is, knock down a lot of the number of ensembles in the short range and really short range. Like you're saying, day 1 or 2, you really don't want the influence of those ensembles in there all the time. And, certainly with the resolution, at least we're getting the European at this point, but the latency of that and its persistence of that, because of its latency, you would just keep regurgitating the same stuff over and over again. So, it would be nice if we could have something like a blend href, basically, is what it is. And that's all you really kind of need. You don't really need to complicate this in days 1 to 2. And if you ask me, maybe you just run the blend like the globals, where you just do extended just 4 times a day, and what you got, and just run it at a smart time, and that's the end of it. And maybe you can do some more fancy things on the machine during those hourly stuff. I don't know, but I mean, these are just things I'm thinking about.
No,
As
and
well as Jeff.
I think another question that I raised, and at least the feedback I gave for the survey I helped develop is, when you're in these situations going forward and you're talking about regurgitating the same stuff, and is it ever appropriate? And again, we're not going to answer this yes or no right now, but is it ever appropriate to say, all right, well, I've been making adjustments to the NBM every cycle because these changes that have been needed. Well, that's going to be my starting point, the official that's in the database. I'm not going to copy the NBM back in only to make the same changes I've been making for the past 5 model cycles. So, I think that's it's more of a philosophical discussion that maybe for another webinar, but it kind of relates to that a little bit, because that can be something that frustrates forecasters. It's like, okay, well, somebody just spent 9 hours making a forecast and they had to adjust the NBM. I don't want to undo all that. There was a reason they did what they did. We're just going to just edit from what they did as needed, not reinvent the whole wheel every time.
I completely get it, because sometimes there isn't enough new data, or that maybe those models aren't handling things right anyway. So it's new, but who cares? So then you're wasting your time doing it. So you're not really moving the needle much. So I completely understand what you're saying.
But on the contrary to that, if half the offices are saying, well, that's what I'm going to do, the other half saying, well, I'm going to put the NBM in, now you have a collaboration issue. So again, that's why I think these are all very important things to be thinking about and discussing.
Great.
All right. Well, I think it's time to wrap up here. But again, certainly anyone is welcome to reach out to us with follow-up questions.
Yeah, I just want to say to Jeff, Dave, thank you so much for taking the time this morning, cracking open the week fresh on a Monday with a very big webinar covering a lot of ground, a lot of parts of NBM What's Ahead. This has really been a helpful discussion, and of course, for all those watching us later, this has been recorded, so feel free to share it around, and we'll have this uploaded to the Eastern Region Science Sharing Google site page. Hopefully later today, tomorrow, depending upon when I get this webinar. This is longer recording than usual, so it could take a little longer to get it. And thank you to Paul for working with me as well to coordinate this. And we'll be coordinating more conversations, folks, moving forward about these topics on future questions. And if you've understood anything today, we have a lot more questions to answer. So we'll have a lot more conversations about this moving forward, regionally and nationally, for that matter. So with that said, thank you all for attending and for your time and for your questions, and have a great rest of your Monday. Thanks all.
Thank you. Have a good day.